Integration using the substitution method, part 1. The integral of x squared times sine of x cubed dx. Here I have a product and a composition, so I can't attempt to integrate each piece separately here. I'm just going to move forward with the substitution method, or I'm going to refer to it as a change of variables. Right now, I'm in the variable x, and I'm going to change to doing a substitution method with a change in variables to u. I'm going to start by letting u be x cubed, the part inside sine of x cubed. So I'm going to let u be x cubed. And then I'm going to take the derivative of u with respect to x. So du dx is equal to 3x squared. And I'm going to multiply the differential dx to the other side. So du is equal to 3x squared dx. So far, I'm able to change the x cubed into another variable, into u, but I would need to somehow change x squared dx into u's. Well, notice du is equal to 3x squared dx. So there's that x squared dx part. So I'm going to simply divide both sides by 3, or another way to think about it is multiply both sides by a third. So a third du is equal to x squared dx. So I will perform the rest of the change of variables by replacing x squared dx with a third du. So let's go ahead and rewrite our new integral in this change of variables. So it's going to be the integral, so this is equal to the integral of, I'm going to have that 1/3 du. That's going to replace x squared dx, so we always keep the differential in the back, and I'll keep the coefficient 1/3 in the front. Sine is going to stay there, and x cubed is going to get replaced with u. So I'm going to have sine of u du. So 1/3 sine of u du is my new integral, and this has a general antiderivative. So I can keep that coefficient 1/3, and the antiderivative of sine u du is negative cosine. So we have negative cosine of u plus c. So we changed variables over to u's so that we could find an antiderivative in u, and once we've done that, we'll substitute our u equals x cubed back in to get us back to the original variable x. So we have negative 1/3 cosine of x cubed plus c. Now before moving on, you may have learned to apply the change of variables in a slightly different way, so I just want to cover that briefly. So it's still going to start out with u equals x cubed. The derivative du is 3x squared dx. But then what some are taught to do is divide both sides here by 3x squared, so solve for dx. So then what's going to happen is you're going to leave x squared, you're going to replace x cubed with u, so sine of u, and then you're going to replace dx with du over 3x squared, and then you're going to simplify or cancel out the x squared. So here what will happen is x squared over x squared is just 1, and so we're left with that 1/3 sine of u du. So here is another way of thinking about it if you've learned this method, as opposed to just seeing that replacement of x squared dx getting replaced with a third du. So just be careful that you never want to have two different variables involved in the differential and in the integrand. Let's try another substitution method. We have the integral of e to the x all over the quantity e to the x plus 4 cubed dx. So this time we're going to go ahead and let u be the quantity e to the x plus 4. So we often want to let u be the quote-unquote inside of a function. So on the previous one, it was inside of the sine function. Here, e to the x plus 4 is inside of this power of 3. So we're going to let u be e to the x plus 4. And now the derivative, du, is e to the x dx. And so notice that I exactly have e to the x dx left over. So that's really how we know that we have chosen a good u, is that the derivative, or at least a multiple of the derivative, is multiplied in the rest of the problem. So e to the x dx is right there perfectly, so I can perform my change of variables. I'm going to have that this is equal to du, and then over u cubed. So replacing e to the x plus 4 with u and e to the x dx with du. So this is my new integral to find the antiderivative of. And so in order to find the antiderivative of this, we're going to rewrite this as u to the -3 du, so that we can apply the power rule for integrals. So we're going to rewrite this as u to the -2 over -2 plus c. So the whole idea is to get to integral with u involved, but that has some general antiderivative. So we can apply the power rule for integrals on u to the -3. So we do that, and once we've taken the antiderivative, then we can plug our u back in, our e to the x plus 4. So we'll go ahead and rewrite this as -1 over 2, and instead of u squared on the bottom, I'm going to put e to the x plus 4 squared on the bottom plus c.